In this video, we are going to tell about one of the classical problems of antiquity. This is called duplicating the cube. The problem goes like this. In long time ago, in 428 BC, this is a myth, okay? The Athenians, suffering from a devastating plague, told the gods to stop the plague or as to avert the plague. Now, they took them to the famous oracle of Delos, which was only second to the famous oracle of Delphi. The oracle had a cubical altar, and the question was to double the volume of this cubical altar. The Athenians dutifully doubled the linear dimensions of the cubical altar, length, width, and height. However, the gods were still not pleased, and the terrifying disease continued to spread and kill. This is a myth. However, here the question was to double the volume of the cube. However, the Athenians increased the volume eightfold, and this is where this classical problem of antiquity, duplicating the cube, comes from. Now, actually, I found a proof to prove that this problem is impossible to do exactly with a scale and a pencil and all. Let me show it to you. Suppose we have a cube here. Now, its side will be of value A. Now, the volume of this cube will be A cubed. So the question is to double the volume. Now, that means that the volume of this cube should be changed to 2A cubed. Now, you separate the 2 and the A cubed. Now, and then you have to take the cube root of that value to get the length of its side. And only when you know the length of its side, you can start drawing the cube. Now, A to the power of 3 into the cube root is just very easy, because the exponent of A to the power of 3 and the cube root cancel each other out, leaving just A. However, as you well know, the cube root of 2 is supposed to be an irrational number. So, because of this, and since A is a rational number, then that means that an irrational number multiplied by a rational number will always be an irrational number. At least almost always. So, thus this problem is impossible to do with the means of the scale and pencil and all. Now, I also saw that this duplicating the cube can be applied to any dimension. Here is a square, and I've applied the same concept, but actually, let me show you. Suppose we have a shape which is like this cube. It has a dimension D. D is a certain dimension. Now, its side will be assumed to be A. Thus, its hypervolume, what we'll be calling the space occupied by this figure, will always be A to the power of the dimension D. Now, as we know, always we all will take the d root of this. Here the question will be to double the hypervolume here, which would means 2 and multiplied by e to the power of d. Now, of course, we'll take the dth root of this to get its side, and then only we can start drawing it. So here the hypervolume hv will, when always taken the df root, will give us a as the exponent here, and the root will simply cancel each other out to give a. However, always the df root of 2 is there, and that will always be an irrational number unless the thing is a line or point. The points of double thing don't exist. Thus, we have proved that this problem is impossible to do in 2 or more dimensions with the means of a ruler and all.